My name is Doug Owsley. I'm a forensic anthropologist with the Smithsonian Institution's National Museum of Natural History. We're here at the RAPID conference, and I've just given a presentation that shows how these additive technologies enter into my work. Now, I'm a forensic anthropologist, so what that means is that I work with law enforcement agencies, medical examiners, police, in the identification of human skeletal remains. I get involved in cases where you can't look at the person, can't tell who the person is just by their appearance. So I'm dealing with badly decomposed remains, I'm dealing with skeletonized remains, and most of my work is centered on examining the person, the remains, to determine who it is, the positive identification, and then also to provide information on what happened to them, what the cause of death is. In this, if you look at my career, and I've been doing this work for over 30 years, this conference has all different types of technology that are now influencing my field. For one thing, I do a lot of scanning, and there's different scanning projects that include CT, computed tomography, laser scanning, white light structured scanning. All of that enters into either my research or my forensic investigations or my exhibit work. One of the things that we have, and one of the reasons I was at this conference, is because we used a lot of additive technology in our exhibition at the Smithsonian's Natural History Museum entitled Written in Bone, Forensic Files of the 17th Century Chesapeake. And one of the things that we wanted to do when you're doing a museum exhibition, this has been a very interesting, exciting project, and really it explains my field of forensic anthropology, but then it shows you how you take these techniques and step back in time, how you can learn about the lives of people that lived hundreds of years ago. And in this, when you're working with a museum public, you want to bring lots of senses to bear on their experience. For one thing, it's not just visual, it's not just reading about it, but for instance, touchable models. And to do this, for instance, we would take actual bones, either scanned bones, laser scanned bones, for instance, or through computed tomography, and develop files that would allow the replication, the rapid prototyping, for instance, of these objects, so that they could be reproduced, for instance, as titanium models, allowing the public to normally, these are very fragile specimens that they wouldn't be able to handle, but to allow them to actually touch and feel and see these types of materials. In the same sense, one of the things that we include in this exhibit are facial reconstructions. And with facial reconstructions, I worked with sculptors for many years, over the decades, and we began to really understand this process of doing a facial reconstruction. And when I look at you, when I see you, I see the bones underneath, but in the same sense, when I'm looking at a skull, I'm starting to see some of the features of that individual. When I'm working in law enforcement on an unidentified set of remains, it just doesn't seem to fit anybody that's from that local area. Sometimes we'll do a facial reconstruction, and I've had cases, for instance, where we can produce it, the police will show that facial reconstruction saying, have you seen someone that looks like this person? And from that, it'll get a cold case, a case that has no leads. Somebody will say, you know, that sort of looks like it. And I've had, in my experience over the years, I've had cases where, for instance, once that reconstruction is out there, somebody will recognize some features of that, and that will lead to a possible identification that we will then go through other means of establishing for certain the positive identification of that individual. Well, in the museum experience, in Written in Bone, for instance, for one thing, we do facial reconstructions that are forensic sculptures. And with those forensic sculptures, we will often sometimes do life-size, full body, based on measuring the skeleton, measuring the height of the individual, very careful in the field and in the laboratory measurements of the body. But then we'll work with the forensic sculptors, the artists, and do this blending of science and art to show what someone that lived 300-400 years ago looked like, or much older in time. So for instance, when I'm doing a facial reconstruction, rather than if it's going to be one based in clay, for instance, if it's going to be one based in clay, I'm going to put facial tissue thicknesses, for instance, and we'll do some anatomical rendering of different muscles, for instance, to build it back. But I'm not likely to put those markers on the actual skull, on the actual bone. Instead, I need a model of it. And I need a high resolution model. So we'll, for instance, scan it, or we will CT it. And from that, then through stereolithography, I can produce a hard copy. And I'll usually actually produce one that is going to be the template for the reconstruction, and then I've got the actual specimen, and I'll go back and forth. I'll have the actual skull go back and forth and make sure that the skull defines the basic features, where your eyes are, your mouth, your nose, all of that information, but then we'll begin to blend into it, and I'll continuously be comparing back and forth to see whether we have the slope of the forehead right, the brow ridge development right, all of those features. Now, that's just the tip of the iceberg for me, in the sense that, for one thing, in my forensic work, I testify, not uncommonly, as an expert witness in criminal proceedings. These are going to be homicides, and I will be explaining what the bones tell me. Well, there are different ways that I will present that evidence in a courtroom. Good, high-quality photography is essential. But in the same sense, computer models may be useful. And especially, for instance, photography, for instance, of things that I see in the computer and I put into virtual reality that allow me, for instance, to interpret a wound, to see when it's hard to visualize inside, to use, for instance, computer tomography, for instance, to study the external surface, which I can see, but more clearly see the internal surface, to look at the internal structure. And so these different scanning techniques, these different types of software that are really software that I'm just learning about, didn't even know existed a few years ago, they're entering into my field in so many different ways. They shape the future, and they allow us to extract more and more information from the skeleton. Most people are not aware of the wealth of information that can come from a skeleton. It can tell you so much about the person, about the life of that person, not just about what killed them, but about the life of that person. And my role as a scientist, my role as a museum curator, and as an exhibition curator, is to explain that information effectively to the public. And with that, all of the high technology that I can bring to bear on that, including the things that are being talked about at the RAPID conference, that's the best way to proceed. If you'd like more information about the Written in Bone exhibition, go to the National Museum of Natural History website. It's a very good website on this, and one of the things that I might call attention to is a particular feature, it's a particular component that is actually a webcomic. And this is an award-winning webcomic. It focuses on one of the skeletons that we excavated in the Chesapeake area. It's a true story. It is a homicide several hundred years old. And from that, you have this graphic novel that really allows you to more or less explore and learn about the evidence and see the evidence as it was uncovered, as told through the eyes of a young intern who was doing work at the site and who actually discovered the skeleton. And from that, also then, the beauty of it is it takes you off into different sections that allow you to see the actual bones, the actual artifacts, high-resolution photography. So that webcomic, if you're my age, a comic isn't quite what you think, but this type of graphic novel is an excellent educational learning tool, especially for middle school, high school age students, teaching you about what the bones show, how you determine male from female, for instance, all applied to that particular story. One of the partners that we worked most closely with in terms of the RAPID conference and our Written in Bone exhibition is medical modeling. And medical modeling provided a number of touchable models for us in use in our forensic anthropology lab. It's a part of the exhibit, actual touchable models for the sight impaired, but actual just the public to be able to hold very fragile objects, feel them, see what the different dimensions are, and they produced them in different types of photopolymers, as well as titanium models, different types of ways of supporting our work at the Natural History Museum.